Welcome to the Dev Journal, where I am Sloan. And today we are witnessing a massive shift as high-efficiency artificial intelligence models and local coding tools move processing power away from the cloud, while massive hardware titans like Apple find themselves stuck in a $4 trillion sideways holding pattern. We are beginning with the release of the Alibaba Qwen 3.5 medium series, a mixture of experts model featuring an incredible 1 million token context window that proves massive scale is no longer limited to data centers, but is now a significant milestone for developers needing local power. We also explore the new command line interface for local software development from OpenAI, an integration that allows for a seamless lifecycle right on your machine and raises serious questions about whether the traditional cloud giants can maintain their dominance in a future defined by localized computing power.
Sloan, that localization trend is why Google DeepMind is pushing even further with AlphaEvolve by using large language models to drive semantic evolution for multi-agent reinforcement learning algorithms, a sophisticated approach to algorithmic growth that could eventually outpace traditional human-designed systems as we start the show.
Alibaba is completely shifting the landscape for deep code-based analysis because the default context window of 1 million tokens removes the constant headache of complex retrieval augmented generation, chunking, and allows developers to drop an entire repository into the model to get coherent answers without losing any critical context. Beyond the massive context, having native support for tool use and function calling built directly into these models allows teams to interface with internal application, programming interfaces, and databases immediately, which reduces the friction usually found when trying to glue third-party artificial intelligence into existing legacy software systems. The model also benefits from a sophisticated 4-stage post-training pipeline that uses long chain of thought cold starts and reasoning-based reinforcement learning to ensure the system is not just predicting the next word, but is actually following a logical path to solve complex problems for reliable automation. However, the real story for the engineering teams is how Alibaba managed to pack all this capability into a much smaller active footprint than we have seen before. So Vance, I am curious if the specific math behind their mixture of experts routing actually holds up when you look at the efficiency claims.
The internal metrics are actually quite startling because the 35 billion parameter model only activates 3 billion parameters during inference, representing an 86% reduction in active parameters per pass compared to the previous 235 billion parameter generation, which drastically lowers the hardware requirements for local servers. The technical breakthrough here is the hybrid architecture that integrates gated delta networks for linear attention, alongside standard gated attention blocks, to finally address the memory footprint bottleneck that usually plagues large context models and allow for much higher throughput without requiring an impractical amount of high bandwidth memory. Even the larger variant, the 122 billion parameter model that only activates 10 billion parameters, shows that they are prioritizing specialized expert routing over raw size to create a system that is far more responsive for real-time engineering tasks than the older and much larger versions. This focus on architectural efficiency and localized execution is part of a much broader trend toward local system-level automation that is currently pushing OpenAI to move beyond the browser and launch their own command line interface for integrated software development lifecycles as we transition into our next story.
Bringing the power of large language models directly onto the local machine via that command line interface represents a fundamental shift in how we build software. By moving operations natively to the hardware, open artificial intelligence effectively eliminates the frustrating latency and connectivity issues that have historically plagued traditional cloud-based integrated development environment extensions. This new approach means developers are no longer tethered to a stable internet connection just to get intelligent code suggestions or architectural advice. The immediate responsiveness of a local system allows for a much tighter feedback loop during the development process, which keeps engineers in a state of flow for longer periods of time. It is particularly telling that open artificial intelligence is utilizing this specific tool internally to facilitate their own software development lifecycle as a form of dogfooding. When a company relies on its own instruments to build the next generation of products, it proves they have high confidence in the reliability and the general utility of the system. Making this available to both free and paid users suggests a massive scale for this experiment in local system-level automation. However, I wonder if giving an automated agent this much control over the machine is actually a safe bet. So how are you looking at the underlying security risks of this command line tool?
The lack of environment isolation for these local agents is a glaring oversight that presents potential system security vulnerabilities for any professional environment. Giving a local agent direct access to compilers, debuggers, and file systems without a sandbox creates a massive attack surface that could be exploited by malicious code or unintended actions. Open artificial intelligence is already issuing warnings that running unverified artificial intelligence-generated shell commands via the command line interface can result in catastrophic local data loss. Rolling this out to the casual users on the free and go subscription plans is a recipe for disaster because novice developers might not understand the risks involved. While the performance gains from direct hardware interaction are measurable, the cost of a single mismanaged command could be the loss of an entire file system. We are seeing a move away from the safety of cloud containers back to the raw metal, which requires a level of oversight that many automated systems are not ready for. This shift toward local execution is just the beginning as we pivot from agents executing commands to agents fundamentally rewriting core algorithmic logic. We are now seeing research into how these systems can evolve themselves, specifically with the latest developments coming out of Google DeepMind regarding multi-agent reinforcement learning systems.
The latest research from Google DeepMind suggests we are entering an era where large language models are no longer just assistants, but are becoming the primary architects of complex systems. By utilizing Gemini 2.5 Pro, AlphaEvolve is actually rewriting the underlying symbolic logic and control flows within multi-agent reinforcement learning algorithms. This transition from simple hyperparameter tuning to deep semantic evolution represents a fundamental change in how we develop high-level software. Instead of humans laboring over every line of code, the system autonomously crafts new variants that exhibit behaviors we might never have conceived on our own in such a short period of time. The results are quite staggering when you look at the utility of the discovered variants, like the volatility, adaptive, discounting counterfactual regret minimization model. This specific variant outperformed existing industry baselines in 10 out of 11 tested game environments, proving that this automated pipeline is ready for serious commercial applications across many different sectors. Seeing an automated agent consistently beat human-designed algorithms across such a wide variety of scenarios suggests we have crossed a significant threshold. I am curious if the specific mathematical optimizations found by this system actually make sense from a traditional engineering perspective, or if they are just lucky quirks in the data.
The logic being generated is far from random and actually reveals some highly sophisticated insights into algorithmic convergence. For instance, AlphaEvolve autonomously discovered a hard warm start threshold that intentionally delays policy averaging until iteration 500. This specific delay allows the system to stabilize before committing to a path, which significantly improves the final convergence. We also see the system implementing an exponential weighted moving average to dynamically adjust discounting, based on the magnitude of regret and learning instability. This is the kind of nuanced mathematical solution that usually requires months of academic research. Yet the artificial intelligence identified it as the optimal way to manage volatility within the environment. It even goes further by using the softmax hybrid optimistic regret policy space response oracles, which implement a hybrid meta solver that anneals a blending factor from 0.3 down to 0.05. This demonstrates a deep understanding of how to balance optimistic regret matching with softmax techniques over time for precision. The discovery of an asymmetric strategy or training uses time averaging, while evaluation uses a reactive last iterate strategy, shows how far these agents have come. It is a sharp contrast to see this level of rapid algorithmic evolution, while we simultaneously watch massive hardware giants like Apple face much slower financial cycles and stagnant market movements. Moving from the rapid-fire world of algorithmic evolution to the lumbering giants of the public markets reveals a stark contrast in momentum. When a company reaches a $4 trillion market capitalization like Apple has, the sheer mass of the entity creates a gravity that resists sudden movements without an incredible external force. The technical indicators currently reflect this massive inertia, with a 21-day sideways outlook that shows no sign of breaking. A relative strength index of 52.45 is almost perfectly neutral, indicating that for all its size, the stock is currently lacking any directional conviction from the broader market participants right now. While many focus on the $98.77 billion in free cash flow, I am looking closely at that current ratio of 0.89. It is a surprising liquidity flag for this size of company, suggesting that despite massive gross margins of 46.91%, short-term obligations are a concern. With the next earnings announcement not scheduled until April 30, 2026, we are looking at a massive stretch of time without a significant fundamental catalyst. This lack of news makes it difficult to see how the price moves toward the average institutional target of $293.07 anytime soon.
Does that lack of immediate price movement overlook the massive structural strength being built into their long-term services strategy, projecting that segment to reach $123.28 billion in fiscal 2026, with 13% growth, is why 65.17% of the company is held by institutions. Their ability to maintain a net margin of 26.92% while growing revenue at 6.43% year-over-year is remarkable for this scale. It suggests that even during these quiet periods of sideways drift, the operational engine is running with efficiency that most smaller firms simply cannot replicate. Even with a current price of $272.14, the narrative remains one of stability rather than stagnation for the long-term investor. This is a business that relies on its massive ecosystem and high margins to weather the storms while slowly expanding its reach into every corner of the global consumer services market. It is a fascinating juxtaposition to see these multi-year financial cycles playing out for hardware titans while software agents evolve their entire logic overnight. As we wrap up today, it is clear that while artificial intelligence moves at the speed of thought, the financial reality of global hardware giants remains anchored to a much slower rhythm.
Watching Alibaba push the Qwen 3.5 mixture of experts models with a 1 million token context window, alongside open artificial intelligence moving into the command line interface, shows the rapid edge shift. Meanwhile, Apple sits with a 0.89 current ratio, stuck until their earnings report in April of 2026.
If we consider those technical leaps Vance just highlighted, it becomes clear that the center of gravity is shifting toward the developer. While the hardware titans remain locked in a $4 trillion sideways drift, the real momentum is happening at the edge, where these nimble agents are rewriting how we build and execute software. As we watch this divergence between the lightning speed of software evolution and the glacial pace of massive corporate financial cycles, one wonders which force will ultimately define the next decade of growth. Thank you for joining us on the Dev Journal today. We will be back tomorrow to look at the next wave of technical breakthroughs.